Imagine a number 93 billion light-years. That is the diameter of the part of the universe we can see. Looking at these figures, it's easy to fall into the illusion that endless expanses lie before humanity, waiting for their explorers. But the harsh truth, which science popularizers usually keep silent about, is that of all this colossal territory, we will never be able to master even 1%. And the reason here is not at all a lack of resources, not the weakness of our engines, and not the brevity of human life. We are stopped by the fundamental laws of nature themselves, which have set up an invisible barrier forbidding us to leave the limits of a tiny local area. Space is not just huge, it is in a state of continuous expansion, and the speed of this process has long outstripped any of our theoretical possibilities. In the very second that you delve into the essence of these words, thousands of distant star systems forever cross the line beyond which they become unattainable. They disappear beyond the cosmic event horizon, becoming ghosts whose light we can still catch, but whose planets we will not touch today or in a million years. We are trapped in an expanding chamber whose walls are moving away from us at a speed exceeding that of light. Let's cast aside the fantastic plots about intergalactic empires and warp jumps that cinema has fed us for decades. In reality, we face a phenomenon that physicists call the cosmological horizon. This is not just a line on a map. It is the physical limit of our influence. There are areas of space that are moving away from us so fast that even a ray of light launched in their direction will never close the distance. This seems like a violation of logic, but space itself is capable of stretching faster than light, and this does not contradict the theory of relativity, because information does not move through space. The fabric of existence itself expands. If we try to calculate what volume of the universe is actually available for colonization, the numbers turn out to be frightfully small. Our fate is limited to the so-called local group of galaxies. This is a small cluster where gravity is still able to withstand the general scattering. Everything beyond this gravitational castle will sooner or later hide in eternal darkness. We live in the era of a cosmic window, when the sky is still strewn with the lights of other galaxies, but this window is slowly closing. Billions of years from now, our descendants looking into telescopes will see only emptiness, because expansion will carry all other objects beyond visibility. The tragedy of our situation is aggravated by practical difficulties that turn even short interstellar jumps into a suicidal adventure. Space is not a vacuum. It is an aggressive environment filled with dust, gas, and radiation. When a ship accelerates to relativistic speeds, any microscopic particle turns into a projectile possessing the energy of an atomic bomb. A collision with an interstellar hydrogen atom at a speed close to that of light generates radiation of such power that biological life inside the ship will be destroyed in a matter of moments. To protect the crew, shields meters thick of lead or ice would be required, making the mass of the ship prohibitive for any engine. The energy problem is another insurmountable censor. Even if we learn to use the annihilation of matter and antimatter, the amount of fuel needed to accelerate and then decelerate a massive ship exceeds all reasonable limits. We find ourselves facing a paradoxical choice. Either fly slowly and spend thousands of years on it, risking crew degradation and system failure, or fly quickly and perish from a collision with cosmic dust or radiation. Physics does not yet offer a golden mean that would allow us to travel comfortably between stars. We often dream of how humanity will settle Andromeda or other distant systems, but we forget about time. Time in space is not just a coordinate, it is a merciless enemy. Due to the effects of time dilation predicted by Einstein, those who go on a distant journey will forever lose touch with Earth. They will return to a world where centuries have passed, where their civilization may already have disappeared or changed beyond recognition. Each such expedition is a break in continuity, the creation of a new branch of humanity that can never become part of a single whole. We are doomed to fragmentation if we ever decide to leave the cradle. Ultimately, we must ask ourselves the question, why does space keep silence so stubbornly? The Fermi Paradox, asking where all the other civilizations are, finds its bleakest answer here. Perhaps the great filter is not war or ecology, but precisely this physical isolation. Perhaps every intelligent life in the universe is locked in its own little gravitational prison, unable to shout out to its neighbors across the expanding abyss. We see billions of galaxies, but for us they are only scenery, unattainable mirages in the desert of space. Trillions of years from now, when the last stars in the local group go out, and expansion finally isolates our corner of space, the memory of the great universe will be erased. If intelligence still exists by then, it will be convinced that its galaxy is all that exists. It will have no evidence of the Big Bang or the existence of other worlds. We are in a privileged moment in history when we can still realize the scale of our confinement. This knowledge is bitter, but it gives incredible value to our here and now. Our planet is not just a launch pad, it is the only real chance we have. Instead of dreaming of conquering Andromeda, perhaps we should realize that our lot is to arrange that tiny space that is allocated to us by the laws of nature. We are witnesses to a great spectacle that will soon end. The universe is expanding, cooling, and striving for thermal death, where there will be neither light nor information left. In this context, every step we take, every scientific discovery, and every attempt to understand the structure of the world is a rebellion against entropy. We are the eyes of the universe through which it looks at itself while there is still something to look at. Are you ready to accept the fact that we may never leave the limits of a few neighboring star systems? That the sky we see is a vanishing nature? This realization should not lead to despair. On the contrary, it emphasizes the uniqueness of our moment. We are those rare creatures who manage to catch the universe young and inhabited by galaxies. Our mission is not in territorial expansion to the ends of the universe, but in preserving that flame of consciousness that accidentally flared up on the outskirts of the Milky Way. This flame is the only thing that opposes the eternal cold of the expanding void. Are you interested in learning exactly how we can most effectively use the tiny resources available to us? Are you ready to explore the limits of the possible within our little prison cell? If you feel this strange mixture of humility and excitement in the face of infinity, then our journey is just beginning. We cannot change the laws of physics, but we can learn to live by them, turning our imprisonment into the greatest achievement of reason. Fermi Paradox lies in the question, why is the sky black at night? If the universe is infinite and contains an infinite number of stars, then at any point in the firmament we should see the light of a star, and the sky should shine brighter than the sun. The fact that it is dark proves the universe is either finite in time or expands so quickly that the light from distant objects simply does not have time to reach us. This emphasizes our isolation and the finiteness of the visible world. The time dilation effect, according to the theory of relativity, is a curse for colonizers. When traveling to a distant star at near light speed, months will pass for the crew, and centuries on Earth. This makes the existence of a single interstellar civilization impossible. Any colony will instantly become a cut-off island, forever lost to the metropolis in time, and not just in space. The heat-death paradox of the universe says that entropy always grows. Sooner or later, all stars will burn out, black holes will evaporate, and matter will disintegrate. We live in an exceptionally rare period, the era of stars, which accounts for only a tiny fraction in the history of the universe. Most of the time of the universe's existence will be a cold, empty, and absolutely black abyss. The paradox of the future observer is a frightening hypothesis that in hundreds of billions of years, the expansion of the universe will carry all other galaxies so far away that their light will no longer be visible. Civilizations of the future will be convinced that their galaxy is the only one that exists in the void. They will have no evidence, relic radiation or redshift, to understand that there was once a Big Bang. This makes one wonder, what has already disappeared from our field of view that we cannot even guess about? The Fermi Paradox in the context of the Great Filter suggests that there is some kind of obstacle that prevents life from becoming interstellar. Perhaps this filter is physics itself. If overcoming interstellar distances requires energy comparable to the energy of an entire planet, then any civilization may be doomed to perish in its home system without ever managing to go beyond its limits due to a lack of resources or the complexity of technologies. The zoo or isolationism hypothesis claims that even if contact is possible, it may be pointless. Due to the huge distances, a signal from another civilization will travel for thousands of years. When we receive an answer, the civilization that sent it may have long since disappeared. Dialogue between worlds turns into an exchange of monologues between the dead, which makes attempts to search for brothers in reason meaningless.